Hello friends and welcome back. So in this session we are going to cover a very important and critical topic which is the heap dump. Okay, the understanding of heap dump, how to collect the heap dump and how to do the analysis of the heap dump. Okay, so we have covered the heap in detail in the previous session what exactly is the heap. Okay, and so now because we have a good understanding of heap, okay, so it's very easy for you to understand what is heap dump, how to collect it and how we analyze the heap dump. Okay, so now let us first start with the introduction. What is heap dump? Okay, so let me enable pen. Okay, so a heap dump is a snapshot of all Java objects in JVM memory at a point in time. Okay, so what we have learned about the heap dump. Okay, so heap, not about the heap dump, but about the heap. Okay, so heap is a small portion of your RAM, right? In the OS, we install the JDK, and your application server is running using this particular JDK, right? And then it initiate one JVM. Okay, so in the operating system, we have physical RAM. Okay, and whenever we define any of the server, okay, so it allocates some portion of the RAM to this particular JVM. For example, 1 GB. Okay, I have defined the sorry, I have defined the minimum and maximum heap size as 1 GB. So what will happen here? The 1 GB will be allocated to the JVM. This particular JVM, right? This is the heap size. This is the heap size of your JVM. Okay, and what we have inside the heap size, we have a Java objects, right? And we have learned in detail what are the Java objects in the heap session. Okay, so that means whenever your server is up and running, you have deployed some application, users are accessing your application, which is executing some business logic. Okay, so that time it create the multiple Java object inside your JVM memory, which is your heap size, right? Which is your heap size. So in that case, a heap dump is a snapshot of all Java objects in the JVM memory, right? So that means at a particular moment, when your JVM, or we can say when your server is processing the request, at that time there are multiple Java objects are there inside your JVM heap, right? So you can take the snapshot of JVM at a particular time. That means whenever you are executing the heap dump. So what will be inside the heap dump? It will be the snapshot of all the Java object that has been created inside your Java heap, right? So specifically in a simple way, what all are the objects or what all are the classes in your Java, okay, that is inside your JVM heap size at that particular time, okay, which is accessing your heap size. Okay, now what is the purpose of heap dump? Why actually we take it? Okay, so there are multiple situations for that troubleshooting purpose. We take the heap dumps, like the memory leaks, insufficient heap size, excessive object creation, stuck sessions or caches. Okay, so that means what does it mean? Okay, when we say memory leak, okay, so memory leak again we have discussed in the heap session, but let me explain you again. Okay, so memory leak in the sense like suppose that you have a heap size of 1 GB. Okay, your objects are getting created inside your heap whenever the users are accessing the applications. Okay, so whenever they access the application request process, it allocate inside the heap size, and when the request is completed, it get free up from the heap size. That means whatever the Java objects that has been created by an application, once the processing is completed, it will delete from the heap size. Okay, and what is the process that clean the dead objects from the heap size is the garbage collection, right? Sorry. So garbage collection is the process which automatically clean the dead objects from the heap size. Okay, but many time it is happened that whenever the application execute, it allocates some heap size. Okay, and when the request is completed, so whatever the Java objects that has been created in your heap, okay, that will not mark as unused. Okay, so that means if any of the Java objects, okay, will not mark as unused or the dead objects, GC will not clean that, right? So if GC will not clean that, then that particular object will keep remain inside the Java heap. Okay, but actually that request has been completed. The difference is that the request is completed and this object has to be cleaned from the heap size, but due to certain problems or regions, object is not marked as dead or unused, so GC will not clear it and it will remain inside your JVM heap. So what will happen in that case? Continuously, gradually, if this kind of a problem persists, your heap size utilization will go up and at a time it will get exhausted. 1 GB is the total heap size, if the objects are not getting clear from a heap size, the heap size utilization will keep increasing, and at a moment where the maximum heap size reach, okay, it will your heap size will get exhaust. So in that situation, okay, so in that situation, you need the snapshot of your heap. Why? Because you should understand what all are the objects that is there inside your heap size, so that you can understand why are the dead objects are not getting clean, what all are the objects which is taking the largest space in your heap size. Okay, so that means you take the complete snapshot of your JVM at particular moment to understand the objects utilization that is created inside your heap size. Okay, so many times it is happened that you have an insufficient heap size. Okay, you do not have a memory leak, but you see that the memory utilization is very high. The objects inside the memory that is getting created is valid objects. Okay, and they are using the memory as expected. Okay, so that means you may have an insufficient heap size, and then you may need to tune, you may need to increase the memory utilization. If you have defined 1 GB of the heap size, so you may need to increase it to 2 GB or maybe more than that. Excessive object creation. Okay, so it is always recommended that you should not create multiple objects or unnecessary object in the code. Okay, because every object is going to take the some space in the memory, in the heap. Okay, so if the excessive objects are getting created, then developers look for the code why on where this excessive the objects are getting generated by the code, and if it's really necessary to generate, if we can reduce that number of objects, so they work on that. Okay, stuck sessions and caches. When you have a stuck sessions where the sessions are getting stuck, you have some cache problems. Okay, which is contributing for the memory problem. So all this snapshot helps to identify all these problems. So common symptoms include server hang. If suppose that you have a problem with the memory, your heap is getting exhausted, so your server may get hang because it's not able to process the request. Your CPU utilization will go high. Application may slow down. Okay, and in fact, JVM also can crash or restart if it is not allocate to the sufficient memory or JVM heap size. It can crash or restart. Okay, so this is called the heap dump, which is a snapshot of all the Java object that is created inside the JVM heap size. Right. So now hope it is clear to you what is the heap dump. So now we have a different ways to take the heap dump in the WebSphere, and then there are certain tools that we use to analyze the heap dumps. Okay. So very first thing to generate the heap dump, a very first and simple way, you can generate it from the console. Okay. So for that you have to go to the troubleshooting section. Inside the troubleshooting we have the Java dumps and core. Okay. So here you can see the different servers, DMGR, node agent, everything is there. So you can take particular server for which you want to generate the heap dump, and then you can click on the heap dump. Okay, so this will generate the heap dump for you, and the location of heap dump is inside your profile location. Right, so you have the WebSphere installation location, then you have a profiles folder. Inside that we have all the profiles. So for example, this is the profile for server 1, okay, for which we have taken the heap dump. So it will automatically create it inside your profile folder, and this is the name of the heap dump file. And if you see here, the extension of the heap dump that is generated from the console is .pht. Okay, so I will share more information on this in the next few slides. Okay, so this is the first way to generate from the console. Now we have the second way where you can generate the heap dump using the command line. Okay, command line, we have the WSA admin utility, okay, which is inside your bin directory. Okay, so with the help of this WSA admin utility, we can generate the heap dump for any server. Okay, for whatever server you want. Okay, so this script you can utilize for the automation purpose, or maybe if you want to take the thread dump from the command line, right? You may not have access of the console. Okay, due to certain restrictions it is not accessible, or maybe you have a certain kind of automation in your organization where you want to generate this particular heap dump using the command line. Okay, so for that you can do the automation. You can utilize the WSA admin utility. Okay, so you can create one object JVM, and inside JVM object you can define all the important parameters that need to be defined. Okay, for example, type is JVM and the process is the name of your server. So here we are going to create the heap dump for server 1. So whatever the server node or DMGR or node agent you want to take the heap dump, you can change the name here. Okay, so name you can say in the console, the whatever the name that you have. Okay, and then you can provide the name here. Once this object is declared, then you can run the admin control.invoke utility, and here you have to invoke this JVM object which you have defined here, right? And then generate heap dump. So this command will generate the heap dump inside the same profile directory. So this is the second option. Third option is x-x dump. Okay, so this is specifically the JOpen or OpenJ9 format for the SDK or you can say for the Java, that is from the web IBM. Okay, so okay, I have discussed this earlier as well, that here IBM doesn't use the traditional Java, which is from the Oracle. Okay, it has own open source Open J9. Okay, which is utilized internally by your WebSphere, which is automatically installed when we install the WebSphere. Okay, specifically using the online repositories. Okay, so we have one option called hyphen xdump. Okay, so what is the purpose of xdump? Xdump is an option which you can utilize, like you can add this particular xdump parameter in your JVM, just like we add the heap size, the garbage collection JVM parameter. Similarly, we can add the xdump parameter as well, and this xdump provides some multiple options, okay, which we can configure in the command line, so that it can reflect it in the JVM at the startup. Okay, so it help us to configure multiple things, like suppose that we have an out of memory problem. So what is the out of memory problem? So this out of memory problem occurs, okay, when we have problem with the JVM, or when your heap size is getting exhausted. Okay, your server get crash. Okay, and at that time it throw the error, out of memory error. Okay, so out of memory, there could be multiple reasons. It doesn't mean that if you are getting the out of memory problem, that your heap size is exhausted and you need to increase the heap size. It's not true, because there are multiple sections inside your JVM. Okay, there are multiple places, and which can cause for the out of memory problems. I will explain you some different scenarios in next few slides. What could be the different reasons for out of memory problem? Okay, but one thing is clear, that you have some problem in the heap size. Okay, or maybe related size, or related native heap, or native memory, which is specifically related with the JVM. Okay, so when we this out of memory occurs, okay, so that means when the JVM in IBM WebSphere application server control allocate more memory because the Java heap or native memory is exhausted. That means simple, when your heap or the native memory is outside your JVM heap. Okay, so native memory part is the outside of JVM. It's not part of a JVM heap. So when these two things are getting exhausted, okay, so then we get the out of memory problem. Okay, so during the out of memory, your server will get crash, right? So now suppose that your server is running, and then suddenly out of memory problem occurs and your server get crashed. So you will not get the opportunity to generate the heap dump, because server is crashed, right? So you need some mechanism, like before exiting, okay, you have automatically generate the heap dump, so that you can do the analysis why the server was crashed, because in the real time you will not get the chance to generate the heap dump manually if the server is crashed automatically at any time. Okay, so for that we have some parameters that we can define with the help of xdump. So this will help us to generate the automatic heap dump when the server is crashed. Okay, so now here you can see there are the different out of memory exceptions. Okay, and there are the different reasons for that. Okay, the very first thing, if the out of memory problem occurring in your main JVM heap. Okay, so you will always see out of memory and then Java heap space. So if it is a Java heap space, then definitely it is a problem with the JVM main memory. Okay, then if you have if you are seeing out of memory problem, but GC overhead limit exceeded. Okay, so if you are seeing out of memory GC overhead limit exceeded, that means JVM spending too much time in garbage collection. So that means your garbage collection is trying to clean your JVM heap size, okay, for the unused object, dead object, but your JVM is spending too much time in executing the garbage collection, and it is not able to free as much as memory. So that means there is some problem with the heap, because your garbage collection is not able to clean your heap size properly. Okay, now if you have an out of memory problem in the meta space, so meta space, what is meta space? We have discussed in detail in the heap section, right? Earlier we had the permgen, perm parameter, which was inside the JVM heap. Okay, and now from JDK 8 onwards, this permgen is replaced with the meta space. So meta space is outside the JVM. Okay, for example, 1 GB you have defined for your JVM. So we define the meta space separately. Okay, for example, 12 MB for the meta space, and there is a specific argument for that. Okay, right. So you will get the out of memory in the meta space. Okay, so similarly you have multiple different reasons. So what all I am explaining here, if you are seeing the out of memory problem, okay, it doesn't mean that you need to increase your JVM heap size. There could be multiple reasons for out of memory. Okay, and some of them are related with the native Oracle from native Java from the Oracle, but some of them are related with the IBM JDK as well. Okay, and specifically apart from that, there could be some more out of memory errors that is related with the IBM JVM. Okay, but only thing that I'm trying to convey here, If you think that out of memory error is coming, you have to look for the rest of the error stack, okay, where exactly it is coming, so that you can take the appropriate action accordingly, not blindly. Okay, so this is a parameter that you can add in your JVM, okay, to automatically collect the heap dump whenever your out of memory error occurred in your JVM and your server is getting crashed. Okay, so this will give you the liberty to generate the heap dump, okay, when you do not get time to act when the server crash, okay, and then that file you can use for the analysis why the server crash or why the out of memory error is coming with the help of your heap dump. Okay, so now when it comes to the heap dump analysis, so analysis is mostly, if I talk about the understanding of the region why the memory the your JVM heap is taking lot of memory, and then why the multiple objects are getting created, why the objects are taking so much of space inside the heap size. Okay, so this is specifically developer related, as in WebSphere admin, okay, or we are working in a support. Okay, so you should understand the complete end-to-end process. The very first thing, you have an understanding of heap size. What is heap size? What is the meaning of objects? Okay, whatever the objects that we are getting created into the heap size, and how to collect the heap dump, what are the different ways. Okay, and then at least initial understanding what are the tools are available and how we can do the analysis with the help of tools. So once the heap dump is generated, you can open the heap dump in the tool and you can look for the big initial analysis. Okay, what that heap dump is talking about. Okay, what all are the objects that is created inside the heap, what is the total space that has been taken by the particular object. Okay, so you can see here the screenshot of one of the tool. So these are the different objects that is inside the heap size. Okay, and for each and every object, how many instances are created for that particular object. For example, there's a byte object, there's a character object. So how many instances are created for that particular object type inside the heap, and how much memory is occupied. Okay, what is the percentage of memory that is occupied by that particular object. So these kind of information you can get, but mostly it is helpful for the developer. What I'm talking about here, as an admin or a support engineer, you should be aware about the complete end-to-end knowledge of the heap dump, how to collect, how to check in the tool, what to check in the tool. Mostly we check the object, total number of instances created by the objects, and then the which object is creating or taking the high memory. And then from there, it is the work of developers, okay, to look for the code, which part of the code is generating so many instances, so many objects, why it is taking the so much of memory. That is completely analysis or fixed by your developers. Okay, but at least till here, the information you have to share with the developer, whatever we have discussed so far. So there are a few tools that we mostly use for the heap number analysis. The very first thing is the IBM heap analyzer, okay, which is a specific tool from the IBM. Okay, and then we have the open source Eclipse mat tool, okay, which is the most popular heap dump analysis tool, which is the Eclipse mat tool, which is an open source. So IBM heap analyzer you may not able to download freely, it may be you have to get some license for that, but Eclipse mat is free. You can download it from the Eclipse website. I will show you. Okay, and then you can start the analysis of your heap dump. So, and this is the screenshot of the IBM location or IBM URL for the tool that is from the IBM. Okay, for the heap dump analysis. Okay, the one thing that you will see here, note that the heap dump are platform agnostic and can be analyzed on any platform regardless of where created. That means the heap dump tool or you can say heap dump is completely platform agnostic. Okay, that doesn't mean that you have to, if you have generated a heap dump and then you have to use some specific tool or for the analysis. Okay, you can use any tool, either IBM tool or you can open source tool for the analysis of the heap dump. Okay, but only one thing is, when we generate the heap dump in the IBM WebSphere. Okay, so this IBM WebSphere generates the heap dump with the extension .pht, which is called the portable heap dump. Okay, and if you have a knowledge of the traditional Oracle Java, where like we have the WebLogic application server. Okay, so there when we generate the heap dump, it generates the heap dump with the extension of hprof .hprof. Okay, and this particular heap hprof format is can easily open in the mat tool. Okay, so Eclipse mat you can download, and inside the file option we have the file called open, and when you open the heap dump file, if it is a .hprof, then this mat tool, okay, understand this file and hprof file, and it can open the heap dump. But in the WebSphere, the heap dump extension is .pht, quotable heap dump. Okay, so your Eclipse mat cannot open this file directly unless you are installing the respective plugin. This is the one of the thing that you have to understand if you are going to analyze the heap dump in the Eclipse mat or the WebSphere. Okay, so you need to install a particular plugin. Okay, and which is the IBM Diagnostic Tool Framework for Java, DTFJ. So this is the plugin that you need to install in the mat tool. Okay, so for that you need to open the mat tool. Inside the help section you will get a install new software section. So there you can add the repository for this particular tool. Okay, and after adding the repository it will show you which is the product that is part of this repository. You can select that and install. So once this particular plugin is installed, then you can open this .phd heap dump in the Eclipse mat tool as well. Okay, so next I will show you the execution, like the different ways of generating the heap dump, how to generate the heap dump, where it is generated, then from where you can download the Eclipse mat, how to open it in the Eclipse mat, and then with the help of this particular plugin, and how it looks like, how the mat tool looks like, what is the initial, even this mat tool automatically do the analysis for you as well. Okay, you just need to open the heap dump and it will automatically do the analysis and it will show you the result on the screen. Okay, so it does a lot of work for you automatically. Okay, so these are all things we are going to see in the next session. Okay, and after that other important stuff we are going to cover is the process. What are the process, threads, thread pool, thread states, and how we deal with the threads, and then your thread dump as well, which is defined refer as a Java core. Okay, in the IBM WebSphere.